right, let's get going. Hello, and welcome to this Morpheus Tech Brief on deploying OVA appliances. I'm Martez Reed, Director of Technical Marketing with Morpheus Data. Before we delve right in, let's talk about what an OVA appliance is, or an OVF appliance. Sometimes you'll hear that phrase used, the two interchangeably. For those that are familiar, particularly in the VMware space, this is a pretty common aspect of working in those environments. The format does support deployment or export, import or export into various other environments, whether that be Zen Server or Hyper-V or public clouds, technically. So the OVF format is an open format that is utilized, as I mentioned, by various different hypervisors and platforms. The goal typically is to export a bundled or packaged application that includes the virtual machine. For those that are familiar with Docker containers, it's a very similar paradigm in that I want to bundle up the application along with the underlying infrastructure. In the case of the OVA appliance, we're talking virtual machines as opposed to containers. The difference between the OVF and the OVF from a technical standpoint is that the OVF is composed of multiple files. So when you go to deploy an OVF or download an OVF for deployment, you'll see multiple files included as part of that download. The OVA looks to streamline that by bundling all of those packages up into a single file or archive. So at the core, that's the primary difference between an OVF and an OVA. So we talked about deployment of those applications. So as an example, oftentimes various applications are deployed utilizing this format. And as part of that deployment process, what you'll get is a prompt for information. So as an example, we have here on this particular slide, it's asking for IP information or network configuration information to configure the appliance. So that's done or facilitated through the use of OVF properties. And so what this allows from a use case standpoint is the ability to be able to inject those particular options or inputs during the deployment of the appliance to streamline the installation and deployment of that particular application. So once again, really focused on simplifying the process, bundling everything up from an application-centric perspective, in which a vendor, such as Morpheus or another third-party vendor, could deploy a application into an environment via the user and really streamline that process by injecting those inputs or those pieces of data during the deployment of that particular appliance. So there's a number of common examples. So certainly those familiar with VMware environments are familiar with the concept or thought of deployment of appliances like vCenter or VCSA into a VMware environment. And during that deployment, you're prompted for information on configuration for that particular appliance. Those are injected via the OVF properties, things like VROPs, as well as various other VMware components are deployed utilizing this capability. Additionally, as I mentioned, various third-party vendors, such as like F5 for load balancers or network security devices, various other components in a VMware environment are deployed via OVA appliances. So now that we've taken a look at what OVA appliances are, the primary use case and why someone would leverage it, let's carry on. So the Morpheus platform added support for injecting OVF or OVA properties, technically it's OVF properties, the two in many ways could be used interchangeably, was added in the 6.3.0 release of the Morpheus platform. It is the standard release branch of the platform. Those changes or those updates will be made available for the long-term support release in 7.0 when it is released next month. So for those that aren't on 6.3.0 or later, something to look forward into in 7.0 when that is released. The Morpheus platform is utilized and leveraged to automate the deployment of workloads into various different environments that do include VMware vSphere environments. Not only does it support the ability to be able to deploy a single instance or virtual machine, the platform supports the ability to be able to deploy complex multi-system environments utilizing Morpheus's blueprinting capability. The reason for mentioning this is that a common use case for OVA deployments is into various full environments, whether it be for testing purposes. As we see here on this particular slide, oftentimes in VMware environments, there's a desire to be able to deploy a nested lab environment for various testing of upgrades and changes and automation that doesn't break or impact a production environment. So it affords a number of capabilities to be able to quickly simulate or test a given environment, uh, utilizing the capabilities that are offered utilizing VMware's virtualization, and particularly nested virtualization when you start talking about things like ESXi. And so a number of these components can be deployed utilizing standard virtual machines, whether it be like Active Directory, utilize a Windows machine, automate the installation, deployment, configuration of Active Directory in that particular system. When it comes to things like the NSX Manager or vCenter, those are packaged as OVA appliances. And so there's a need to be able to leverage the OVF properties during deployment to automate that process as well and be able to stand up a full environment utilizing a Morpheus blueprint and then be able to potentially expose that via a catalog item. So there's a number of reasons why, from a benefit standpoint, it makes sense for Morpheus platform to have the capability to support the injection of those properties during the deployment of a workload. So now that we've talked about Morpheus' support for OVF properties or supporting OVA appliances, let's take a look at what that looks like from a use case standpoint. And then we'll walk through the Morpheus platform to see how it all comes together. So in our example, we have Lauren. Lauren wants to deploy a Fedora CoreOS virtual machine based on an OVA in the environment. For those unfamiliar with Fedora CoreOS, it is a minimal operating system primarily focused on container hosting, so running containers on the particular platform. The thing of note with Fedora CoreOS is that it is deployed via an OVA into a VMware vSphere environment. And so that means that we need to have the ability to be able to inject those OVF properties during the deployment of this particular system in order to be able to utilize or leverage the system. There's two pieces of data that the OVA is asking for during deployment. It is an encoding. So in this case, the encoding is utilized to specify the data payload that's going to be passed. So we see that we have the guest info.ignition.config.data that is expected from this particular appliance. So the encoding is going to specify what format that data is being passed as. So in this case, it'll be base 64. And so we need to pass the data. So the data or data that's being injected into the CoreOS OVA is the configuration for this particular appliance. In the case of CoreOS, its specific syntax and language is what is referred to as butane. So in the case of the Fedora CoreOS, there's two properties that we're passing. In the case of other virtual appliances, there may be a handful of others, and they may be something as simple as a simple string or a number or an IP address. But in this case, we're walking through a more complex example to be able to showcase the full functionality of the Morpheus platform to orchestrate this end-to-end process with some additional complexity. So in the case of a more simplistic scenario, we would just simply inject the appropriate data into those fields. So we'll walk through what that flow looks like to actually take it end to end. So as part of the deployment workflow, first thing that was done was to download the Fedora CoreOS OVA appliance. Went to the website, downloaded the OVA. Now that it's been downloaded, it needs to be uploaded to the Morpheus platform in the virtual images section. So let's take a look at that within the Morpheus platform. So library, virtual images. So in this case, I've already done the upload process, but if I were to do it again, I would go to add. In this case, we see VMware, VMDK /OVA/OVF/OVA. I'll click that. I'd fill in the appropriate pieces of information, things like the name, the labels, the requisite operating system, memory. so forth and so on. I would click add and then upload the file. So that's going to upload it to the Morpheus platform to be able to leverage it to provision or deploy from the Morpheus platform into the VMware vSphere environment. So let's take a look at the existing virtual image that we have here. A few pieces of information that I filled out, not very extensive, but what I focused on was the name, the operating system as the primary core capabilities. So pretty straightforward, pretty standard in terms of what I configured for this appliance. So the virtual image is now available in this particular environment. So let's take a look at what the next step is in this case. So what we would do is we would create a node type to associate the virtual image to, and then we would configure the VApp properties for the node type. So let's take a look at blueprints. Let's go to node types. So we have Fedora CoreOS. So prior to 6.3.0, you would come in here to a VMware node type in the platform. What you would see is the extra options. What you would not see are the VApp properties. And so what I've done is I've configured or added the VApp properties. So these are the fields that you would see when you go to deploy an OVA or OVF appliance in VMware. It would prompt you for pieces of information to specify or inject. And so in the OVF itself, it includes the field mapping for these particular properties. So for those unfamiliar with the OVF, you can open up the OVF in a text editor, and you can see the specific properties that are exposed via the OVF. So in this case, we have the mapping for these two options that we talked about earlier, which were the data encoding and then the data itself. So as I mentioned, in the case of the encoding, we're specifying base 64. In this case, this is a static property that we're just going to simply hard code to the node type, because in this case, it's never going to be anything different than base 64, which works out well. But in many cases, we want variability. We want to be able to dynamically inject data for the appliance during the deployment process to ensure we don't run into things like conflicts with naming, or we want the variability that offers that benefits of customization. So in the case of the data, what we've done is we've specified that it will map to a custom option or an input within the Morpheus platform. That will allow us to be able to inject the configuration into this particular appliance during deployment time. So outside of that, nothing else in particular has been configured. Only the required fields for this particular node type. So continuing on, we've uploaded the OVA, we've created a node type that maps to the virtual image. Now let's take a look at the instance type and instance layout that are going to map to the node type. So for those that are familiar with the Morpheus platform, pretty straightforward, pretty standard in terms of what we're going to do here. So we're going to have the instance type. Nothing particularly special here. One thing we've done is we have that input that is mapped here that we saw that was injected into the node type. So we're mapping the input to the node type. One thing in particular is we've decided to hide it. So we'll take a look at what that looks like and why we actually hid it a little bit later. So instance type has an instance layout that then maps to the node type. The other thing that we have on the particular layout is a workflow associated with it. So we're going to do some automation to orchestrate that full process to generate the actual payload that's going to be defined for this particular OVA appliance. As I said, much more complex scenario than may be needed in most cases, but there's value in seeing the capability of the Morpheus platform to be able to orchestrate many of these complex end-to-end processes. So we've walked through the instance type, the instance layout, the node type. We've seen all those mapped together. I'm sure those probably all make sense, given that they're very similar to how you would do it just with a standard virtual machine within the Morpheus platform. So now let's take a look at the automation that's being utilized to create the configuration for this particular payload. So what we saw was a workflow attached to our instance layout to handle provisioning. In this case, what we're doing is we are leveraging the configuration phase to dynamically inject the data payload during the deployment of that particular workload. So in this case, we have 3 tasks that are running or executing. So we're going to take a quick look at these particular tasks. In and of themselves, this isn't particularly important to know the nuanced detail of how this is configured or those specifics. It's really to showcase the capability of the Morpheus platform to be able to automate and orchestrate that end-to-end process. So let's take a look at our first task from the platform standpoint. So it's a Python script. There's a lot going on here, but at the core, for those unfamiliar with Butane, what it looks to do is specify a YAML file that is injected during the deployment of the workload. Uh, in many ways, similar from a functionality standpoint to something like Cloud Init, to be able to specify settings during the provisioning time of that particular workload. So all that's being done here is a YAML payload is being created to specify various components that go into that. A couple of things to point out. So what I'm doing is specifying the host name as an example for this particular instance after it's deployed, utilizing Morpheus host name. So leveraging Morpheus variables to define configuration for this OVA appliance at runtime. Some user information, and then we're printing out the YAML output from this particular task. Reason we're doing that is we're chaining the tasks together in this workflow to pass output from one task to another. So we're spitting out a YAML string that is going to a single value. We'll take a look at what this output looks like on an existing example instance in a minute. And so after we've created our butane file, what we're going to do is we're actually going to run a utility that I've deployed on this Morpheus instance known as butane. And so what butane is going to do, the butane program is going to convert that YAML into the appropriate JSON that is termed as an ignition file. And so what we're doing is we're taking the results of that create butane file task, running them against this butane command, base 64 encoding them. So we talked about that encoding earlier for the VF or OVF properties. And so we're encoding that and then we're spitting that out once again, utilizing a single value result type, and then going to leverage that in the subsequent task. So finally, what we're going to do is we're going to inject that ignition file, or technically it's the ignition data, we haven't written it to a file, into our OVF properties via the custom option that we defined. And so in this example, we're taking the results from that butane convert command, cleaning up some of the data based upon the way it's outputted, and then we're specifying or injecting that information into the configuration. So we've got custom options and then ignition. So what we're doing is before Morpheus goes to deploy that Fedora CoreOS appliance, what we're doing is on the fly generating this content to then be injected during the provisioning of that workload. So we have the provisioning workflow. Provisioning workflow is attached to the instance layout, and we have the various tasks to get our ignition file injected into the OVF properties. So let's take a quick look at an existing instance that I have deployed. So this is deployed into my VMware environment, and the items of note are here. So as I mentioned, the create butane file is literally creating a YAML file on the fly for this particular configuration. So one of the things of note, we mentioned that variable being defined. So the instance name for this particular instance was FC01. And so the YAML is being generated on the fly and injecting the FC01 host name into this particular payload. So that allows us to be able to define various concepts or constructs on the fly and then support those being injected into our appliance. We have the butane convert. So what happened was it converted the YAML file into a JSON and then base 64 encoded it. In this particular case, we do see a number of issues that are things like the spaces being not properly handled. So that's why there was some additional configuration or automation in the Python script to handle that. And so what we see is the spec file. And so we've injected the ignition, which is why we leverage that configuration phase to facilitate that automation in this particular payload. And so if I were to go deploy the instance, and deploy a new instance, FCO2, select my network. In this case, one of the things I do want to mention is that in this particular case, I am skipping the agent installation, which is probably going to be applicable for most appliances, given that they're often essentially black boxes or closed environments that may not even support the installation of the Morpheus agent. So I'm going to click next, click complete. So what it's going through right now is actually generating that YAML file, converting it to the ignition file, which is that JSON file, going through the process of base64 encoding that, and then finally injecting that into the payload that Morpheus is going to pass into VMware to facilitate the deployment of the appliance. So if we take a look at the history for this one, before the appliance is even provisioned, what we have is a generated butane file, converted, base64 encoded, and then passed the Morpheus spec. So as I mentioned, the name of this instance is FCO2. We have that configured, injected inline into our YAML file that is then utilized to pass to the particular payload. So when that virtual machine spins up, its host name after that configuration is done is going to be FCO2 as we specified as part of this process. So a couple of things that have been going on here. We'll touch quickly on the options. So as I mentioned, there was that input that we specified. So in this case, I'm using this as essentially an intermediary holder for data. And so I choose to not expose this to the end user during provisioning time because ultimately there's zero value in this being exposed. And so I've leveraged a hidden input and then programmatically modified the value of this particular input or option type during the provisioning process of that particular OVA appliance. So this is that placeholder that we saw that was utilized on the node type. So that's how all the pieces fit together, in that able to dynamically define this particular VApp property utilizing the hidden input or option type as the placeholder, and then modifying that on the fly prior to the actual deployment of the appliance to ensure it's deployed into that particular environment correctly. So we've walked through all these various concepts and components. Certainly I could associate that with the blueprint to stand up a full environment. Maybe in the case of Fedora CoreOS, I want to stand up, let's say, a Kubernetes cluster as an example, utilizing this functionality and this capability within the platform. Certainly the possibilities very extensive in terms of their uses, and can be utilized to address a number of use cases in these VMware environments. So we've walked through all these various things. That concludes this Morpheus tech brief. Definitely appreciate everyone for joining and taking the time out to walk through this capability.